random events, right? Might as well go random on this one. If you go to page 48, what's our time like? Okay. 48 looks like this. I don't know if you tried it. Chances are you already completed this. If you did, way to go. You're doing fine. But these all have to do with the dependent events, okay? 2 cards are chosen from a standard deck of 52 cards without replacement. That right there should ring an alarm. It's like, okay, so I'm not replacing. If they ask us, it's going to be dependent events where the first affects the second. What's the probability of random choosing 2 kings? Okay, so we want a king first. So how many kings do we have? 4 of 52, right? So that's the probability of the first event. And you want another king. So we're down to 51 and also down to 3, right? So that right there would give you the answer that you're looking for. So that would be 12 over, and my key has the simplified version of this. That's 2652. Okay, very small chance of that happening. What about B? What's the probability of the first card being a jack? We've got 4 out of 52. And a second one is a 10. How many 10s are there? 4. The first one hasn't affected the number of 10s. It has affected the total in this case. So we're still out of 2652. In this case, it's 16 out of 2652, right? So that's kind of like the idea there. Question 6. This one is the one that we talked about today. It's kind of hidden. Math has 5 out of 20 students got an A. If 3 students are chosen at random without replacement, what's the probability that all 3 got an A on a test? Let me just see here. 6. So 5 out of 20. So the first one will be 5 out of 20. And then that student has, one of them has been already selected. So it's 4 out of 19, and then it's 3 out of 18. Okay. So in that case, you get, I have it already simplified. I'm just going to give you that one, 1 over 14. 1 over 114, okay? Simplified. That would obviously be 20 times 3, that's 60 over some big number, okay? What is it? 6,840? Okay. I can already tell that the zeros will simplify, right? And then you can use your calculator to do the magic there. Okay. So the rest I kind of leave that up to you. Let's go to 49. I want to focus in on 11. So I'm going to, if I have time, I'll go to 10, but we'll go to 11 here. 3 cards are drawn. Calculate the following, right? Probably that all 3 cards are aces. I'm just going to set it up for you. There are 4 aces out of 52, 3 out of 51, 2 out of 50. Okay, so that's how you would solve that. And that ends up being, if you do this right, you get 1 over 5525 if you simplify that. That's not where I want to park. I want to get to C here. Probability that all 3 are black cards. How many black cards, right? 26 out of 52. And then it's 25 out of 51. 24 out of 50. Okay. That gives you, if you simplify that, that's, I'm just going to give you this. 0.1176. How's that to mix everything up? 11.76% if you do that right. Okay. Now C. C is where I wanted to end up. Okay. all three are of the same suit. What does that mean? A suit is like, it could be a spade, a club, a heart, or a diamond, right? You want all three from the same. What does that mean in this case? What do I have to do here if you want to consider all cases? Yeah, you can multiply your answer by 4, or think of it as cases, right? In this case, multiplying by 4 is the fastest way of doing it. But if it had been a bag of marbles where you have different colors and different numbers for each of them, then you want to split it into cases. Okay, so 4 cases. Okay, so you've got spade, spade, or a club, club, or diamond, diamond, or heart, heart. Okay, and because they're all identical, it's easiest to just find one of the cases and multiply it by 4. I would agree with that. Okay, so spade, spade would be 13 over 52. Sorry, I'm missing a letter because it's 3 cards every time. Sorry about that. So yeah, no. 13, 52, 12 over 51, and 11 over 50. Okay, and this would repeat itself 4 times. And if you like to save time, this is not the way to do it. Okay, you will realize that this will just continue 4 times. So it's really just 4 times this answer, whatever you get for one of them. Just remember, if you want all of the same color, the same kind, you have cases in front of you, okay? And I get, I think if you go 13 times 12 times 11 times 4, you get 68, 64. Don't multiply the denominators, okay? That one is not lined up with the 4 because it's really 4 over 1. You get 132,600 for that one. You can turn that into a decimal. That's 0.0518 or 5.18%. Okay? So that's how you do those types of questions. I will ask you, I will already give you an AC that I want you to do by tomorrow. So I'm not quizzing you, okay? So for that reason, I'm gonna kind of send more stuff home so we can get it done on time. I hope